Down below your feet, far deeper than any mine or cave, lies a world of profound mystery. It is a place of impossible heat and crushing pressure. At the very center of our planet spins a solid ball of metal. This is Earth's inner core. For generations we imagined it as a simple, unchanging sphere. A silent, steady anchor for our world. It felt like a constant, a truth written in stone, or rather in iron. But science is a story of finding the unexpected. And now, seismic whispers from the deep are telling us something new, something strange. The inner core, our planet's hidden heart, is not as constant as we thought. It appears to be changing. Imagine a journey to the center of the Earth. You would pass through the crust we live on. Then you would sink through the vast, slow-moving rock of the mantle. Deeper still, you would enter the swirling liquid iron of the outer core. This is where our planet's magnetic field is born. And finally, at the very center, you would find it. The inner core. It is a solid sphere of iron and nickel, about the size of the moon. The temperature there is hotter than the surface of the sun. The pressure is so immense that the iron cannot melt. It is a realm beyond our direct senses, a place we can never visit. For a long time, the story of the inner core was a simple one. It grows slowly, freezing from the liquid outer core as the planet gradually cools. This process has been happening for over 1 billion years. It seemed like a slow, uniform process, a perfectly symmetrical crystal growing in the dark. But the Earth is a complex and messy place, and the latest evidence suggests this growth is not uniform at all. One side might be growing faster than the other. The core itself might not be a perfect sphere. It might be lopsided. This single, simple idea changes everything we thought we knew about the engine at the heart of our world. This isn't just a geological curiosity. It's a twist in the story of our planet. The inner core is not a passive bystander. It is an active part of the Earth system. It influences the magnetic field that protects us. It affects the flow of heat that drives geology. To learn that it is changing its very shape and behavior is like discovering that the fundamental rhythm of a song you've always known is starting to shift. It makes you lean in closer. It makes you listen more carefully. What is the Earth trying to tell us from its deepest, most hidden chamber? A new chapter in our planet's biography is being written, and we have just arrived to read the first page. How do you study a place you can never go to? You can't drill a hole to the center of the Earth. Heat pressure. So, scientists had to get creative. They learned to listen. They learned to use the entire planet as a laboratory. The key is earthquakes. When an earthquake happens, it doesn't just shake the ground beneath our feet. It sends powerful waves of energy called seismic waves vibrating through the entire planet. These waves travel from one side of the Earth to the other, passing directly through the core itself. They are our messengers from the deep. These seismic waves are like a planetary-scale ultrasound. As they travel through different layers of the Earth, they change speed, they bend, they reflect, they carry information about the materials they pass through. Scientists set up incredibly sensitive detectors called seismometers all over the globe. When an earthquake happens in, say, Indonesia, a seismometer in Brazil can record the waves that traveled through the planet's heart. By measuring the exact time it takes for these waves to make their journey, and by studying how their paths have been altered, we can start to build a picture of what lies within. It's a form of remote sensing on the grandest possible scale. For decades, this method gave us a blurry but consistent picture. We saw the solid inner core. We saw the liquid outer core. We could estimate their size and their density. But as our instruments got more sensitive and our data sets grew larger, a strange anomaly began to appear. Waves that traveled through the core from north to south seemed to move at a slightly different speed than waves that traveled along the equator. This was the first clue that the inner core wasn't a simple, uniform ball. Something was different about it depending on the direction you looked. The invisible heart of our world had a texture. This is where the story gets really interesting. Scientists started looking at data from pairs of nearly identical earthquakes called doublets that happen years apart in the same location. The waves from these repeating quakes should trace the exact same path through the core. If the core were unchanging, the signals recorded on the other side of the world should be identical. But they weren't. The travel times were slightly different. This tiny, almost imperceptible shift could only mean one thing. In the years between the two earthquakes, the inner core itself had changed. The invisible landscape was evolving. The first major surprise from this seismic data was the idea of lopsided growth. The inner core is not growing like a perfect crystal, adding new layers of iron evenly all over its surface. Instead, the data suggests that one hemisphere of the core is growing faster than the other. Imagine a snowball rolling downhill, but it only picks up new snow on one side. Over time, it will become unbalanced. This seems to be happening at the center of our planet. For some reason, new iron crystals are freezing onto the inner core more rapidly under Asia than they are under the Americas. The heart of our world has a preferred direction of growth. This uneven growth has a profound consequence. The core is slowly changing shape. It's not a perfect sphere. It's subtly, but measurably, asymmetrical. One side is a bit different, perhaps a bit mushier or denser than the other. This isn't a fast process. The changes happen over millions of years. But the fact that it's happening at all is a revelation. It means the deep Earth is a far more dynamic and complex system than we ever imagined. The forces that shape our planet are not symmetrical. There are flows and patterns deep within that create this imbalance, a hidden geological preference. What could cause this? The leading theory points to the liquid outer core. This ocean of molten iron is not still. It is churning with massive, powerful currents driven by the planet's cooling and its rotation. These currents generate our magnetic field. It's possible that these flows are not evenly distributed. They might be pulling more heat away from one side of the inner core, causing it to cool and crystallize faster in that region. In another region, the flow might be slower, or there might even be material from the inner core melting back into the liquid outer core. The core is in a constant, slow-motion tug-of-war with its liquid surroundings. This discovery forces us to rethink the planet as a single, interconnected system. Events in the outer core are directly shaping the structure of the inner core. And the shape of the inner core, in turn, could influence the flow of the outer core. It's a feedback loop happening in complete darkness, 3,000 miles beneath our feet. This lopsided growth might even help explain long-term cycles in the Earth's magnetic field, including why it sometimes flips its polarity. The quiet, steady heart of the world turns out to have a complex and unbalanced life of its own, a secret history written in the slow accumulation of iron crystals. For most people, sunshine has a powerful and positive effect on their mood. It can make you feel more energetic. It can make you feel more optimistic. It can make you feel more alive. This connection is not just poetic, it's biological. Our bodies are finely tuned to the cycles of light and dark. Exposure to sunlight helps our brains produce serotonin, a chemical linked to well-being. It's a natural mood booster. For some people, this connection is even more critical. In shorter, darker winter days, some experience seasonal affective disorder, or SAD. The lack of sunlight disrupts the internal body clock and can lead to lethargy. It can cause sadness. It can cause fatigue. A simple change in daily light can fundamentally alter our inner weather. The sun, 93 million miles away, reaches into our minds and shapes how we feel. This is why light therapy boxes exist. They produce bright light that mimics outdoor sun. Sitting in front of one for about 30 minutes a day can help many people with SAD. It's a conscious supplement when nature isn't enough. We are solar-powered creatures, metabolically and emotionally. Our moods are tethered to a star, the joy of a sunny day, the gloom of a long winter. We are not separate from the world around us. We are part of a vast, interconnected system. Our feelings and consciousness can be influenced by planetary cycles. The tilt of the Earth's axis gives us seasons. The rotation of the Earth gives us day and night. The light from our star fuels our bodies and our spirits. Our inner world reflects the outer world. This connection helps us understand our place in the cosmos. Just as sunlight shapes our mood, so does the rain. A coming storm can change the entire feeling of a day. The air grows heavy, the sky darkens, and a certain stillness descends. For some, the sound of rain is one of the most calming experiences in the world. The gentle patter on the roof can be meditative, helping to quiet a busy mind and encourage introspection. It creates a sense of enclosure and safety, a feeling of being sheltered from the world. For these people, a rainy day is an invitation to slow down, to read a book, to feel cozy. For others, rain brings a sense of melancholy or gloom. A gray, drizzly day can feel oppressive. It can cancel plans, trap you indoors, and literally dampen your spirits. The lack of sunlight and the monotonous gray sky can mirror or even induce feelings of sadness. This phenomenon is so common that we have it embedded in our language. We talk about feeling under the weather. Our emotional landscape can be directly irrigated by the clouds. The weather doesn't just happen around us, it happens within us, shaping our thoughts and coloring our perceptions of the world. This psychological effect of weather is a powerful example of our deep connection to our environment. Our brains evolved over millions of years in constant interaction with these natural cycles. Rain meant water for crops, but it also meant potential floods or the need to seek shelter. Sunshine meant warmth and the ability to hunt and gather, but also the risk of dehydration. Our emotional responses to weather are ancient echoes of these survival instincts. They are a built-in sensitivity to the state of our world, a primitive form of environmental awareness. When we consider how profoundly something as simple as rain can affect our daily mood and thinking, it opens up a larger question. What other, less obvious environmental forces are also shaping us? We are sensitive to light, to sound, to temperature. Could we also be sensitive in subtle and unconscious ways to other planetary phenomena? Could shifts in the Earth's magnetic field, for instance, have a subtle influence on biological systems? While there is no definitive proof of this in humans, exploring the connection between the sky and our feelings reminds us that the boundary between our inner world and the outer world is remarkably thin. So how do we connect the dots? How does a lopsided, changing inner core relate to the sunlight and rain that color our daily moods? The link is not a straight line. It is a long, fascinating chain of connections. The inner core's changing shape and growth patterns influence the churning liquid of the outer core. This, in turn, affects the generation of the Earth's magnetic field. The strength, shape, and stability of that magnetic field determine how well we are shielded from the constant stream of charged particles from the sun. It's the first link in the chain, from deep Earth to near space. The next link connects space to our sky. When the magnetic field weakens or changes, more solar particles can penetrate deeper into our atmosphere. This can have several effects. It can increase the frequency and intensity of the auroras, the beautiful northern and southern lights. But it can also pose a threat to our technological infrastructure. Satellites are particularly vulnerable to these solar storms. They are crucial for communication, navigation, weather forecasting. A strong solar event, less well deflected by a changing magnetic field, could damage or disable these critical tools. Here we find the link to our daily lives. We rely on those satellites to predict the weather. Our meteorologists use satellite data to see where clouds are forming, where storms are moving, and whether the day will bring sun or rain. If our satellite network were to be compromised by increased solar activity, our weather forecasts would become less reliable. That predicted sunny day might turn into a sudden downpour. The forecast that helps a farmer plan their harvest or a family plan a picnic would become less certain. This brings us to the final link in the chain, the connection to our mood. As we've seen, the weather has a direct impact on how we feel. An unexpected rainy day can change our plans and our emotional state. The amount of sunlight we get affects our biological and psychological well-being. So, while the inner core doesn't directly cause you to feel happy or sad, it sits at the very beginning of a causal chain that can influence the technologies that predict the sky, and the sky itself influences our minds. The slow, deep changes in the planet's heart can have faint, but real, echoes in the weather of our daily lives. We stand at a remarkable moment in our understanding of Earth. We have, for the first time, detected a change in the planet's deepest, most inaccessible realm. The inner core is not the static, simple object we once imagined. It is a dynamic world with a lopsided shape and a shifting pulse. It is growing unevenly, and the pattern of that growth is evolving on a timescale we can observe. This discovery is a testament to human ingenuity, our ability to listen to the faintest seismic whispers and translate them into a story about a hidden world. It reminds us that our planet is alive, all the way to its center. This new knowledge gives us a profound sense of connection. The chain reaction is long, but it is there. The composition of the core shapes the magnetic field. The magnetic field guards the atmosphere. The atmosphere creates the weather. And the weather touches our minds and moods every single day. We are not just living on the Earth, we are living in it. We are part of a single, vast system where events in the molten heart can, through a long cascade of effects, be linked to the feeling of sunlight on our skin. Realizing this changes our relationship with the planet. It is not a rock, it is a body. But this discovery leaves us with more questions than answers. We are watching a change, but we don't know where it is leading. Is this a normal, cyclical fluctuation, or is it a sign of a more significant long-term transition? As the inner core continues to evolve, how will it affect the magnetic field over the next century, or the next millennium? Will our protective shield remain strong, or are we in a period of slow decline leading to a future reversal? We have opened a new door of perception into our planet, and we are only just beginning to peek through. So, as you go about your day, feeling the world around you, remember the unseen heart beating far below. It is a heart of iron, 7,000 degrees hot, slowly crystallizing in the dark. Its lopsided growth and shifting rhythm are part of a story that is billions of years old, but a story that is still being written. We are tied to that deep, slow pulse in ways we are just starting to comprehend. The greatest mystery is not what has already happened, but what happens next. As the Earth continues its silent, internal evolution, what will its changing heart mean for the future of life on the surface?